Training R. What is SMW or mmaw or stick welding? Understand the process principle and equipment. Understand different parts of the process and equipment. Understand the functions of the electrode wire, coating and slag. Know how the electrode classification system works. Understand the polarity in SMW welding. Know the advantages, limitations and application of the Smaw. Identify the SMW process variables which control the process. Understand the requirements for the electrode storage and conditioning. SMW stands for shielding metal arc welding. This term is used in Canada, America, other countries except UK. It is also called mmaw or manual metal arc welding. This term is used in UK. Other names stick electrode welding, or commonly known as electrode welding or manual welding. These are non-standard names used commonly in the world. Heat for welding is generated by an electric arc established between flux-covered consumable metal rod, electrode, and the workpiece. During electrode melting, the coating burns and produces gaseous shield which protect the electrode tip, welding puddle and highly heated workpiece from atmospheric contamination. Here an example of small welding machine is shown. The electrode holder and earth clamp is connected to the power source. The electrodes are kept in a portable holding oven. Let's understand the principle of this process. Here as shown, the welding machine is connected to the main power supply. As we switch on the machine and touch the electrode to the base metal, the arc generates. A basic arrangement of Smaw is shown in the picture. A basic arrangement of Smaw is shown in the picture. Now, let us understand what happened at the welding zone. Here 1 and 2 are the part of welding electrode. 1 is the metal. 3 shows the shielding gases which got generated due to the burning of the coating. 4 is the weld pool. 5 is the base metal. 6 is the solidified weld metal and 7 shows the slag. As we can see in the right-hand side video, the melted metal is being transferred to the weld pool in the form of small driplet. The shielding gases are visible too, which are produced by the burning of the coating elements. Red molten area shows the weld puddle. Please take a look to feel the material transfer taking place in the video. Next is a welding electrode. It assesses the consumable as it gets melted during the welding process. ITS is composed of 2 parts. First, core rod, which carries welding current and becomes part of the weld. Second is the flux coating, which produces a shielding gas and can provide additional filler. It also forms a slag, protect weld, helps slow cooling of the weld. Coating also add alloying elements. It also helps for the arc stability. Commonly 50 mm in the market. And the diameters available are 2.5 mm, 3.15 mm, 4 mm, and 5 mm in the market. Next is welding arc. An arc occurs when the electrode comes in contact with the workpiece and completes the circuit like turning on a light. The electric arc is established in the space between the end of the electrode and the work. The arc reaches temperatures of 10,000 degrees Fahrenheit, which melts the electrode and base material. Here different types of welding arc is shown for Smaw. The long arc mean high voltage, and short arc mean low voltage. Next is welding puddle. As the core rod, flux coating, and workpieces heat up and melt, they form a pool of molten material called a weld puddle. The weld puddle is what a welder watches and manipulates while welding. Next, let's see the shielding gases. The shielding gas is formed when the flux coating melts. This protects the weld puddle from the atmosphere, preventing contamination during the molten state. Next is solidified weld metal. As the molten weld puddle solidifies, it forms a joint or connection between 2 pieces of base material. When done properly on steel, it results in a weld stronger than the surrounding base metal. Let's see slag. Slag is a combination of the flux coating and impurities from the base metal that float to the surface of the weld. Slag quickly solidifies to form a solid coating. The slag also slows the cooling rate of the weld. The slag can be chipped away and cleaned with a wire brush when hard. Next, let's understand the polarity in the shielding metal arc welding. In shielded metal arc welding, there are 2 types of polarity. 1. Direct current electrode negative and 2. Direct current electrode positive. Direct current electrode negative, or called straight polarity, is shown here in the figure. Electrode holder is connected to the negative terminal, while the workpiece is connected to the positive terminal. Here more heat liberated in positive pole, and electrode melts off slower, thus results in less deposition efficiency. Next, let's understand reverse polarity, or direct current electrode positive polarity, also called DCAP. Here workpiece is connected to the positive terminal, hence the name called, and workpiece is connected to the negative terminal. Due to high heat at the electrode burn off faster and result in high deposition efficiency. Due to high heat at melting, depth of penetration also increase. Next, let's see the SMW equipment setup. To set up the welding machine: 1. Turn power supply on. 2. Connect work clamp. 3. Select electrode based on its type and diameter. Then adjust output based on polarity and amperage. Next, insert electrode into electrode holder and initiates the pulsing. Now let's understand the SMW process variables. The variables are classified in two types. First is the welding machine variable, which are polarity either DCAP or DCAN. 2. Current in ampere. Second variables are the variables controlled by the welder, which are: 1. Is work angle. 2. Is travel angle. 3. Is arc length. 4. Is travel speed. This has to be noted that AC machines have not a polarity like DC machine. Here we will note: to begin the Smaw process, you must first strike an arc. This can be done using one of the following techniques. Scratch start. Scratch the electrode on the base metal like a match. Tap start. Tap the rod against the base metal. Here electrode angle is shown for single run weld and shielded metal arc welding process. Here electrode angle is shown for single run weld and multi-run weld using the shielded metal arc welding process. Now let's understand the electrode classification system. By knowing it, we can know the properties of the welding electrode, such as its tensile strength, type of coating, welding position, types of current, penetration profile, etc. Here in this example, it's shown for E6011 type electrode. Here E stand for electrode. Here stand for the strength in KSI. Next, digit 1 mean the electrode can be used in all position. Last digit tell us the type of coating, type of welding current we can. Here 1 means cellulose potassium, and this electrode can run on a C, DCAP and DCAN polarity. This electrode will give deep penetration. Here other example of famous electrode E7018 is given. Please have a look and try to decode it. Want to see the all types of electrode, their properties you can find in OSME section 2C. Codes with their properties are given for the viewer reference. Please have a look on each and understand their uses. Next, let's know the important points regarding the electrode handling and storage. 1. Store electrode in suitable conditions and away from high humidity and moisture. 2. Never use wet electrode as they will produce porosity and other welding defects. 3. Never use electrode with damaged coating. 4. Never keep cellulose electrode. 5. Low hydrogen electrode are very critical for moisture absorption. 6. Store the electrode in holding oven after removing from the packets. 7. Never mix different types of electrode in portable oven. 8. For any abnormality in electrode, must inform to the welding supervisor. From their packing must be ensured to properly bake and kept in the holding oven to keep them free from moisture. Low hydrogen, rutile and basic type coating types electrodes should be baked and kept in holding oven. Cellulose types are exception and must never be baked. Portable ovens are used to keep electrode warm at the welding site. Let's see how we can choose the welding current. We can choose current based on the manufacturer recommendation or follow this thumb rule to get to be used as lower and higher range for that given diameter. Another thumb rule shown is for finding the arc length. This table here shows the range of current for various important welding electrodes that can be used as reference. Next, let's see the limitations of the SMAW process. This process has 1. Less deposition. 2. Frequent start-stop points. 3. Need for slag removal. 4. Unusable stubs add to waste of material. 5. Less productivity. 1. These are the major applications of the shielded metal arc welding, can be used for welding of most of the materials. For example, carbon steel, stainless steel, copper, nickel alloys, cast iron, etc. 2. Good to use for field welding. 3. Portable as no external shielding required. 4. Cheaper power source and equipment. 5. Produce radiographic quality welded bosses, used for car facing, overlay. 7. Good to use for maintenance work.